introduction page, introduction to 3 states. Can you see it, chapter 5? Can you guys see it?
Yes, we can.
All right. I am going to go these topics, question from these topics in that order, and try to give you an idea to solve problems and help you out with the test. All right. I'm going to start with introduction to states of matter. Go to the now these are, it went further. First question is about the state of matter. What state has the weakest intermolecular forces, attractive forces? Solid has the highest, liquid has in between, gas has the weakest, and it's not same for all states of matter. Therefore, answer is C here. If I can write down C. Which of the following leads to increase in kinetic energy of a molecule? We talked about kinetic energy is related to motion, movement, or temperature of the molecules. Increasing kinetic energy is related to increasing temperature. Therefore, answer which of the following leads to increase in the kinetic energy of a molecule? The answer is B. Now you have a picture given here. Which physical state of matter is represented by the following model? This cannot be a gas. It's more like liquid or solid. To decide between liquid and solid, if you look at the picture, it's randomly organized. Look like it's not showing motion, but it looked like more like a liquid. Therefore, answer is B. Is a picture represent liquid. So there's a change of substances, states of substances, A to B. Which of the following statement is true? Velocity of the molecule increase. Going from gas to solid is not true. The strength of the intermolecular forces increase, which is true. In a solid, intermolecular forces are higher. Kinetic energy of molecules increase. That's true. Therefore, there are 2 correct answers. Then the D is the complete answer, both included. Therefore, D is the correct answer. Both when liquid becomes, gas become a liquid. Gas become a liquid or solid. Intermolecular increase and kinetic energy decrease. Number 5, the temperature of substances decrease to a very low value. Which of the following models represent the substance at lowest temperature? Lowest temperature is for solid. So B is the correct answer. This has the lowest temperature. When you cool something, it becomes eventually a solid. Okay, there's a calculation. Gas occupies the volume, 6 liter volume, 3 atmosphere. Calculate the volume of the gas when pressure increased to 9 atm. Now this is a Boyle's law type calculation. Boyle's law is P1 V1 is equal to P2 V2. So in this question, this is V1. This is P1. When pressure increase, that's P2. So they are asking V2. What is the V2? New volume. Calculate the volume. So you rearrange this equation to get the V2. Now V2 is equal to, when you rearrange, P1 V1 divided by P2. So you plug in these values. P2 here, V1 here, P1 here. So these values from the problem, 3 and 6. P1 is 3, V1 is 6, P2 is 9. So when you calculate, it becomes 2 liters. Answer is 2 liters. Therefore, correct answer is D. That's how you calculate. You find out the gas law, then find the variables that are missing, then rearrange the equation and calculate the new value. Now about the gas pressures. Which of the following pressure relationship is correct? This relationship is given here. PSI is 760 torr. Now look at the pressure relationship. Which one is correct? This is correct. This is not correct because this one is correct. This is not the same thing. 1 atmosphere is not 760. Therefore, this is not correct. More than one correct answer. No, there's only one. A is the correct answer. So you find out the correct relationship. Now, systolic pressure, which is the blood pressure, 128 millimeter mercury or torr. What is the pressure in ATM? How do you convert millimeter mercury to ATM? The conversion factor is 1 ATM is equal to 760 millimeter mercury. So you have to convert 128 here, millimeter mercury, with the conversion factor. 1 atmosphere is equal to 760. Therefore, it's a division by 760. 128 divided by 760, you get answer. Answer is C, as shown up here. So you can calculate different temperature units using conversion factors. Aerosol can has pressure of 1.86. What is the pressure in units of millimeter mercury? Millimeter mercury is 760. 1.86 divided by conversion factor. This is 80 ATM is equal to divided by multiplied by 760. This is multiplication. You get 1430, which is the B. That's how you convert pressures. Now, we're going to look into this conversion. Scuba diver begins with the tank with this pressure, 2350 psi. What is the pressure in millimeter mercury? So psi is 14.956 right here. This is the conversion factor. So C is the correct answer. I'm going to show another calculation in the next slide, which is similar. So now this is what is in, this is the same question almost. Yes. So I am showing there the tank pressure divided by conversion factor. So I rewrote the conversion factor here. So you get the answer. 2,350 converted to millimeter mercury become 1.21 10 to the 5, which is the answer C. So again, there are calculations like that. This psi to ATM. You use in question 11, you convert psi to ATM by using this conversion factor. 14.695 psi is equal to 1 atmosphere. You get 160 ATM, which is the answer given here for in the choices. Now Pascal is also another conversion factor. So you psi to Pascal is similarly done. You divide this tank pressure by the conversion factor and convert that to 1.62, which is the choice D. So you can see how you calculate. Then this one is tau and millimeter mercury is same number. Therefore, 815 tau should be equal to 815 millimeter mercury. So this is millimeter mercury. This is 1-to-1 conversion. All right. Now we're going to look at some calculations with different variables: pressure, volume, temperature, pressure, temperature, volume, amount of substance or moles, volume and moles, etc. Now if you look at this problem, this is the temperature versus volume. When you're doing temperature versus volume, you hold the amount constant and the pressure is constant. So it says constant pressure. That fits with the Charles law. Charles law equation is this. Now you have to find out V1, what is the volume, what is the, calculate the temperature. You have to find the final temperature, which is T2. You rearrange the Charles equation here. Okay, T2 is, you take it up there and all these cross, you know how to solve a problem like that. So you find V1, V2, T1 divided by V1. All these are given here. So 5 liters now 56 temperature here had to be converted to Kelvin. This is the Kelvin conversion for temperature. This temperature 56 plus 273 Kelvin. Then the V1 is, you start with 3 liters. Then final temperature is calculated. Final temperature is 548, which is the choice B. It's a Charles law calculation. You find the variables V and T. It is asking for final temperature. You plug in the values, you get the answer. New temperature in Kelvin. Which of the following units can be used to measure air pressure? All these ATMs, millimeter mercury, toe, all are used. Answer is D, all. Which of the following is not a unit of pressure? Millimeter mercury is a unit, Pascal is SI unit for pressure, toe is another unit. Hertz, it's not. Hertz is used for frequency, radio waves, etc., light waves. So therefore, it is not a unit of pressure. Answer is D. Which of the following instrument is used to measure the pressure of a gas sample in a container? It's normally when you use mercury J tube, J looking tube, the height of the mercury shows the pressure of the container. So it's a manometer. Manometer is the one that used to measure pressure. Therefore, answer is C. Which of the following instruments is used to measure atmospheric pressure? Atmospheric pressure is measured with barometer. So altimeter is the height in planes. You use altimeter to get the height of the plane. Barometer is the one used for atmospheric pressure. Manometer is for gas containers. Thermometer for temperature. Therefore, correct answer is A. B. B is the barometer. What is the average temperature, average pressure of the atmosphere at sea level? Normally, at sea level, in a given day, atmospheric pressure is 1 atm. Sea level is the standard. So it's 760 atmosphere. This is 760 millimeter mercury is correct. The B is missing here. So only correct answer is A. 1 atmosphere is 760 millimeter mercury. Which of the following is the units, SI units of pressure? Pascal is the abbreviated PA. Pascal is the SI units of pressure. Now this equation is a gas law equation. Mathematical, this gas law is what? When you kept pressure constant, temperature constant, amount of gas constant, is a pressure versus volume. That's the Boyle's law. So Avogadro law is volume versus N. Boyle's law is volume versus P. Charles' law is volume versus T. Combined gas law is everything, P, V, T. Amount is kept. So in each equation, each gas law equation, only these variables. Other two are held constant for Avogadro's law or Boyle's law or Charles' law. So this is Boyle's law. B, V and P is only involved. Which of the following sample would have a new volume of 3 liters if the pressure is decreased from 3 atmospheric to 1 atmospheric pressure. So this is the Boyle's law. Volume is the pressure, new volume. Therefore, V2 is the question. You rearrange this equation to get the V2. Oh, this is the V2. They're asking which one when you start with. Starting V1. So you plug in the values here. P1 is P2 is 3. P2 is 1. This is P2. V2 is 3. So V2 is the new volume. So they're asking what is the volume you start with. So V2 is the question. Therefore, P1 is, this is P1, is 3. So when you do the calculation, you get volume is equal to 1 liter. So this is the only one with 1 liter. So therefore, answer is A. Which of the following laws relate to the volume and the pressure of the gas when amount of kept temperature is kept? Amount is N, number of moles. Temperature is T. This is pressure and volume. This is Boyle's law. So I listed out different laws. Between, this is Boyle's law. Volume is inversely proportional to pressure. When amount and temperature is, then you get this equation. This description fits with the law, Boyle's law. Therefore, answer is Boyle's law. B is the Boyle's law. So that's how you figure out which equation to pick for different calculations. Which of the following is a mathematical representation of Boyle's law? It has to be P1, V1 is equal to P2, V2. So P1, V1 is equal to P2, V2. That's the answer. Which one is the mathematical representation? Let's see what they give you. So these two are out. These are not Boyle's because it's P and T. One of these is correct. Which one is rearrangement of this Boyle's law? The Boyle's law is, this is the correct answer. You can rearrange and get that one, not that one. Therefore, A is the correct answer. So it's a mathematically equivalent expression. Which of the following is a mathematical representation of Charles' law? Charles' law is V1 divided by T1. This is the one. So these are Charles' law doesn't involve volume is, pressure is kept constant. So Charles' law is D. Which of the following mathematical representation is the Charles' law? There's similar to the Boyle's law. We are asking which one is the Charles' law one. It has to be this. You can rearrange this to this one. So answer is C. Select the mathematical expression for the gas flow listed. What is this? We already come up with that. This one and this one is, these two are same. That's Charles' law. So answer is C. Which of the gas law describe the relationship between volume and temperature of a sample of gas at constant pressure? Volume and temperature at constant pressure, sample of gas is constant pressure. Volume and temperature is Charles' law. Charles' law is volume is directly proportional to Kelvin temperature. Equation is V1 divided by T1 is equal to V2 divided by T2. Charles' law involves which of the following? Is it an indirect relationship? No, it's direct proportionality. V is directly proportional temperature. That doesn't involve Charles' law. Fix, yes, number of moles, fix MR quantity. Quantity is mole, measured in mole, that's true. Volume versus temperature. Charles' law is volume versus. Therefore, more than, this is the most correct answer. More than one correct response. D is the answer for that. Which of the following laws relate to the volume and temperature of the gas when pressure is constant? Volume, that's again Charles' law. I am giving you a lot of questions so that you remember the equation. Number 32, which of the following laws relate to the pressure and temperature of a gas when volume is kept constant? That's a PT relationship. PT relationship is called Gay-Lussac's law. Amount in N and volume is kept constant. This is the PT's Gay-Lussac's law. P1 divided by T1 is to P2 divided by T2. Which of the following law is related to process of respiration? In respiration, you increase the lung volume, decrease the pressure in the lung. When you increase the volume, pressure decrease. Therefore, gas flow in inhale. When you exhale, you reduce the volume of the lungs, then exhale. Pressure develop, it pushed out. So it's a Boyle's law, pressure and volume. Therefore, respiration is breathing mainly, is Boyle's law. Which of the following is true of the mercury level at the same both sides of a J tube in a manometer? If the mercury levels are equal, pressures are same on both sides. Atmospheric pressure is same as the inside pressure is same as the atmospheric pressure. So if you have the choices, gas pressure is equal to atmospheric pressure if the levels are equal. If the levels are higher, then there's a higher pressure. Gas has a higher pressure or lower pressure. You can see from the two levels of the mercury in the J tube. Which of the following is the mathematical representation of Gay-Lussac's law? P1 V1 divided by T1 T2. That's the Gay-Lussac's law, holding number of moles constant and volume constant. So D is the correct answer. Which of the following is mathematical? That now we are going to Gay-Lussac. We've gone to Boyle's, Charles, Gay-Lussac. So that's the mathematical equivalent So this is the correct answer. You get rearranging this, you get that equation. So answer is C. At constant temperature, pressure of a 6-liter sample is increased from P1 here, P2 here, V1 here. What is the new volume? You are asking new volume. So this is a Boyle's law calculation. P1, V1. So you plug in the values from this. One is P1. So P1 is 1. V1 is, you look up where V1 is 6 here, divided by P2. P2 is 2 atmosphere. The answer is 3 liters, which is the D. They are pretty simple problems. You have to find the gas law and plug in the unknown known variables and calculate the unknown variables. Now, this calculation is at constant pressure, constant temperature. Pressure is reduced to what is the new volume. So that's Boyle's law again. So new volume is V2. You plug in these values of P1, V1 divided by P2, you get 12 liters, which is the answer D. Now this problem, at constant pressure of the gas is changed from 1 atmospheric pressure to tau. Calculate it. That's Boyle's law. This question is to show that you cannot plug in an equation. The P1, P2 cannot be in different units. So it has to be converted to ATM. The P2 is now 1.5. So 1.5 at the bottom here is P2. P1 is 1 atmosphere. V1 is 10 liters. So you get, when you calculate the new volume, you get 6.67, which is the correct answer. Do you have a question? All right, I'm going to continue. At constant temperature, calculate new, this is again pressure volume, Charles law, Boyle's law. So now this is similar to the problem 39. Now the P1 is in tau. P2 is in ATM. Therefore, you change P1 to 1.5. P1 is 1.5 now. So when you calculate that, you get the answer C. Now, this is a problem at constant pressure, sample of gas. That means T constant, N constant. Volume is given. Temperature is given. Calculate the volume. That's a V2, final volume. That's a V1. That's the T1. This is the T2. That's a Charles law calculation. So you plug in these values in these places for the V2. You get V1 from the problem, T2 from the problem. I wrote down on there. So answer is D. So now this is the similar problem. Only difference is now you're going from 400 to 300, 300 to, so V1, V2 swap, similar problem. When you do that, you get 3 liters. If you look at this problem, and that problem is the same, only temperature is changed. I give you similar problems in case you didn't get the first one. At constant pressure, the temperature of 4 liters. Now you are given in Celsius. Now remember all the gas law calculations. Temperature given in Celsius need to be converted to Kelvin by adding 273 to before do Celsius Kelvin conversion. So I am converting here 25 to Kelvin, 298, 50 to 238. Now the problem is similar. Now you have to get the Kelvin values and plug in the equation. So when I did that, the V2 is equal to, final volume is equal to P. Now this is liter of sample, constant pressure and temperature. Constant pressure. The temperature change from 52. This is similar to problem what we done before. If you look back at it, this is 25 to 50. This one is 50 to 25. It's the same problem. So only thing that temperatures are on the bottom, and here in the last problem, this was kind of on the top, 323. Same calculation. This is Charles law calculation. So let's see this problem. Temperature of a constant pressure. That's Charles law again. Temperature, volume again, okay. Calculate the temperature. You have to calculate the T2. This is T1. This need to be converted to Kelvin. This is the sample V2. That's the V1. So let's see how you do it. First 50 converted to Kelvin. This is Kelvin temperature. So you solve for T2 and plug in the values you got from this. V2 is 6.8. V1 is 233. We calculated 6.5. Then the final temperature is 338. We get the answer B. So that's a Charles law calculation. Which of the following is a mathematical representation of combined gas law? Combined gas law is P1 V1 divided by T1 is equal to P2 V2 divided by T2. P2 V2 divided. That is the D. So now you have idea about Boyle's law, Charles law, Gay-Sachs law, combined gas law. There are a few questions going to be asking for combined gas law in next problems. Which of the following is a mathematical relationship of combined gas law? Pretty mathematical expression. None of them are combined gas law original equation. You have to find which one is correct. P1 V1, P1 V1. This is the correct question answer. Because when you take this T down, T2 down, and T1 down, let's get the original equation. Therefore, answer is C. So this could be rearranged to this equation, which is given in choice C. Equivalent mathematical expression. Now, if you have a balloon that is 2 liters, V1 is that. When the pressure is P1 is the Celsius temperature is 24. What is the volume of the balloon when it raises to an elevation with pressure P2? Now you have to, and the temperature. There's a T1 and T2, both need to be converted to Kelvin. You guys okay? All right. So first you convert Celsius to Kelvin right here. T1 converted to Kelvin. So I did that and plug in the values. I get the 4 liters. This is a combined law gas combined gas law calculation. T1 V1 divided by T2 T1 is equal to P2 V2 divided by T2. So this is a similar problem. Now you don't have to calculate kelvins. They are given directly in Kelvin. Therefore, easy question. So you calculate charge law calculation. Again, you get the answer B. What will happen when temperature of gas is increased from 20 to 40 at constant pressure? Temperature of the gas increase is a new volume. Volume is what happened to volume. You are given several choices. Now increase from 20 to, this is 20. T2 is 40. The ratio of the volume is V1 divided by V2. Ratio become 0.96. 0.96 indicate if volume didn't change 1 to 1 is equal to ratio would be 1. If the volume slightly increase, it can create lower than 1. So answer is D. You have to check with the charge flow calculation about the volume. So this problem is again volume change, temperature change given in Kelvin. So you look into the same data. The V1 divided by V2 is 0.5. That means 0.5, you get V1 divided by V2. V2 is double. So the volume is double. V2 become twice the V1. So similar problems. You plug in the values, you can say where the volume is double, in this case on problem 53. So similar calculation. Okay, a gas expands from initial volume to final volume, final pressure P2. That's a combined gas law. So again, you find the temperature need to be converted to 12 and 23, T1 and T2 need to be converted to Kelvin. where I did it here, adding 273. So when you did the calculation, plugging in T1 value, V1, T2 divided V2, you label whatever the variables given in the problem. So when you calculate that, you get 0.52, which is the B. Which of the following has the law is the main volume is maintained constant? Volume is maintained constant in Gay-Lussac law. Charles law, volume versus T. Avogadro's law, volume versus number of moles. Boyle's law, volume versus pressure. Gay-Lussac's law, volume maintained constant. Which of the following law relates the volume and the number of molecules of gas when volume and N, number of moles are called N. That's the Avogadro's law. Volume is directly proportional to number of moles. Pressure and temperature held constant. Avogadro's law is V1 divided by N1, V2 divided by N2. The Charles law, Gay-Lussac's law, Avogadro's law look similar, except Charles law is for volume T. Gay-Lussac's law is pressure and T. Avogadro's law is volume and N. A sample of carbon dioxide occupies the following liters, 22.4 liters at STP. Which of the following statements sample contains atoms of carbon? That's 1 mole of, we talked about molar volume is 1 mole of any gas at standard temperature and pressure takes up 22.4 liter volume. All right. So there are sample contains carbon atoms. So the following is statement to sample, this sample contains carbon dioxide is sample contains atoms of oxygen. Sample contains molecules of carbon dioxide. The molecules of carbon dioxide is most correct. A is also correct, but it is kind of we are not breaking up carbon dioxide here. Therefore, 1 mole of sample at STP has Avogadro number 6.02 molecules of carbon dioxide. What volume does 1 mole of gas occupy at temperature 273? That's the standard temperature and pressure. 273 is also 0 Celsius. That's 1 mole of oxygen. That's O2. C is the correct answer. Now we on to Avogadro's law. A student has 3 samples of gas at equal volume. 3 gases are oxygen, carbon dioxide, ammonia. All gases are same temperature and pressure. Standard temperature, maybe. Which of the following sample contain the largest number of molecules? They all contain the same. If you have same temperature and pressure, number of particles has to be same. So all 3 gas samples contain the equal number of, that is about the Avogadro's. 1 mole of any particle. Particles are oxygen, carbon dioxide, and ammonia in these samples. The student has 3 sample gases that have equal volume. gases are same, oxygen, carbon dioxide, and ammonia. All the gases are at the same temperature, pressure. That's STP. Which of the following sample contains the largest number of atoms? Now, number of atoms, they all have same number of particles. But ammonia has 4 atoms per particle. Carbon dioxide has only 3. Oxygen has only 2. Therefore, largest number of atoms is in ammonia. Ammonia is the correct answer. C. Which of the following is the correct unit of ideal gas law? This is same as PV divided by NT. It's really Vp divided by NT. That means liter atom divided by mole. Mole is N, T is Kelvin. So therefore, that's the units of ideal gas constant. The value of our ideal gas constant is 0.0821. Calculate the volume occupied 8 grams sample of molecular oxygen at STP. Now you have to find the number of moles in oxygen. How do you get the number of moles? Number of moles is grams divided by molar mass. Grams is given here, 8 grams. Divided by 32 is the molar mass, 16 times 2. 0.25 moles of oxygen, O2. So now they're asking volume. So you do a calculation. Rearrange this equation to solve for V. When you solve for this value is given, this value is known, this value is known, this value is known, you get volume for that. Those numbers are 5.56. That's A. That's the ideal gas law calculation. So seven gram sample of nitrogen. Nitrogen is N2. Molar mass is 28, 14 times 2. Then liters given. Temperature is given. Calculate the pressure of the sample. So to calculate, you have to solve the equation PV-nRT. You have to look for P. N is 2.5. So you plug in the 2.5. This is 2.5. I'm sorry, I left it. R is the ideal gas constant. 283 is the temperature. 2.5 is the number of liters or volume. So you get 2.32. There's a mistake here, 2.5. I left the 2.5. I think this is correct. This is the wrong one. 0.285. I will check that. All right. I am going to show you on my webpage. There's a question and answers for chapter 5. All the calculations are given. All right. You can look into that if you have any questions. So I am going to go through this quickly. You look up in the sample question section on module 3. PowerPoint question and answers. Okay, you will see it there. I'm going to continue this from next week. All right, next Thursday, not next week, and see how it goes. I'm not going to give a test until I am confident that you guys can handle it.